Hello. Yeah, welcome to our live session, our live class. So today we are dealing with the different thing. We are dealing with the magic of numbers. Okay, so just give people a minute or two so that they join our session. Just giving the people a minute or two so that they will be with us. Okay, a minute or two. Okay, so we're dealing with dynamics today. Dynamics. Okay, that is physics. We're dealing with physics 101. Dynamics, the laws of motion. How should you apply the laws of motion to a conceptual question? Okay, so for those of you who are joining, you will find us as we have begun the session. So the dynamics is just the study of forces and motion. So dynamics is just the study of forces and motion. So dynamics is the study of forces in the motion. Okay, dynamics is the study of forces and motion. Okay, now since you are studying the motion, actually there are laws that should obey for you to have a clear understanding of what dynamics is. Since you are studying motion, so you need to know the laws of motion. So what are these laws? These laws actually you even learn them in secondary school. Yeah, the laws you actually learned them. So the laws were: one, you knew the law of inertia. Also the second law of motion. Also what's the reaction law. I hope you can remember those laws of motion. The same laws applies to dynamics. Okay, so one, we have law of inertia. We have law of inertia. Okay, we have law of inertia. So what does law of inertia state? Okay, what does the law of inertia state? So this law actually says that an object will always resist its change in motion. That's the simplest definition I can give you. An object will always resist change in motion. An object always resists change in motion. Actually, there is that long definition. It's not wrong, but it's long. The straight line of motion, whatever. Those things you spice them so that at least things look. But actually, this is the simplest definition that you can know. An object will always resist change in motion. Okay, what will be the second law? The second law, actually, you know it. The second law is the force should be equal to ma. The force should be equal to ma. That's the second law of motion. So this states that for a constant mass, the force applied is directly proportional to the acceleration. For a constant mass, so meaning the mass is constant. So for a constant mass, the force applied is directly proportional to the acceleration. For a constant mass, the force applied is directly proportional to the acceleration. Okay, so that's the second law of motion. For a constant mass, the force applied is directly proportional to the acceleration. These pointers I'm giving you, they are very important when you start solving questions on dynamics. Okay, so number 3 law, we have the reaction law. Okay, the reaction law. We have the reaction law. Okay, So the reaction law says that for every action there is an equal but opposite reaction. For every action there is an equal but opposite reaction. So for every action there is an equal but opposite reaction. Okay, yeah, so that's the reaction law. I hope you get it. Okay, so here are these pointers. So mostly in our calculations we will mainly focus on law 2 and 3. So the law 2 can actually be written as like this. So the law 2, which you know, for a constant mass, the force is applied is direct proportional to the acceleration, can be written as summation of forces should be equal to mass times the acceleration. Do you know what this symbol means? This symbol is called sigma. So the sigma means you are summing up the forces. So this is sigma, and the sigma means you are summing up the forces. Okay, you are summing up the forces which will be applied to the object or whatever the case. Okay, so we move on. These are just general pointers that you need to know. So law 3. So now the law 3 is what brings the concept of the normal force. Okay, so the law 3 is what brings the concept of the normal force. Okay, so the normal force will always be perpendicular at right angles to the surface of an object. Okay, the normal force, I think I should write these pointers. So the normal force will always be perpendicular at right angles to the surface. Okay, to the surface. Or we can have different surfaces of where the object is placed on. So let's say we have the flat surface or an inclined surface. Okay, let me use the back page. Just flip the print paper. Okay, all right. So we can have the flat surface. So this flat surface, we have this object. Okay, so the object is on flat surface. Okay, flat surface. So since we are saying at the right angle, the normal force will always be perpendicular at right angles. Okay, so the normal will be opposite like this. So this will be the normal at 90 degrees. That is the normal. Okay, then at inclined surface, we can have an inclined surface like this. Here we have an angle, elevated angle, the theta. So this is an inclined surface. Okay, so is it Priscilla or Prisca, the one who was asking about the sketching of the diagram? So you should hear and see how you're going to solve those questions. Yeah, so I also give you the example, the exam question. So they say that physics, if you want to fill a physics question, don't sketch. So the free body diagram is very important. So they will just give you the roadmap of how you are going to solve the question. Okay. So we have an object here. So meaning the normal force will just be opposite like this. So this will be the normal at 90 degrees. Okay. Even this one is at 90 degrees. Yeah. So second, you should always draw a force after it it has had its effect. So that is, the arrow should always point away from the object. The arrow should always point away from the object. Let me show you what I'm saying. So we can have like this. Right. So you shouldn't draw the force like this when you're drawing the free body diagram. The force should be always away from the object. So this is the long way. Okay. The correct way to show to draw the force after its effect. I'm saying after its effect. So I'm going to draw it like this. The force should be point away from the object. Then you write it like this. That's the correct way of writing. Okay. So now let's move to another thing. We talk about friction. Let's talk about friction. Okay, friction. We all know friction always opposes the movement of an object. So if an object wants to move right, friction will point to the left. That's the thing. That's the opposition. Okay. If an object wants to move to the right or want to move to the left, the object will pose to a different position. Okay. So let's have this object. You can have this object. The force is going like on the right direction. So meaning the acceleration is on the right. All right. So now the friction will oppose the motion. So the friction is going this side. So that is the friction. Okay, friction. Right. So but friction under dynamics, friction specific under dynamics, there are two types of friction. So we have there are two types of friction. Okay. So under dynamics we have two types of friction. We have kinetic friction. So kinetic meaning is for a moving object, and you have static friction for an object at rest. So we have two types of friction. Number one, I'm saying we have kinetic friction for moving object. Two, we have static friction for object at rest. Static, it's not moving. Okay, it's not moving, static. So the thing that you need to know is that the friction has a very intimate relationship with the normal force, which will give rise to the expression that I will show you. So the friction, okay, so these that have been attracted by the right, so I'm recording from outside. All right, so friction has a very intimate relationship with the normal force. So friction can be like this. Friction, let's say we are talking about the static friction. Okay, static friction, right? Static friction should be equal to the coefficient of static friction. I'm going to say the coefficient of the static friction. Okay, coefficient of static friction times the normal. Okay, so you're going to write like this. Friction, that is Fs subscript small s, should be equal to, so the coefficient of static friction, you're going to write it as mu. So it's more like a u, it's mu, like so, mu, not u but mu. So it will be like it will be a mu s, then the capital N. So this is the coefficient of static friction times the normal force. Okay, yeah. So don't mind the insects that are moving on my paper. I'm recording from outside. Yeah, all right. So friction, or if it's kinetic friction, you can write it like this. Friction or kinetic should be equal to the coefficient of kinetic friction. The coefficient of kinetic friction times the normal. Okay, the coefficient of static friction times kinetic friction times the normal force. Right, now you can write it like Fk should be equal to mu k. This will be mu k, the mu symbol, then the subscript small k, then times the normal force. Okay, so for flat surfaces, the normal will always be mass times gravity for flat surfaces. For flat surfaces, I'm saying flat surfaces, the normal will always be equal to mg for flat surfaces. Now for inclined planes, the normal will always be, for inclined planes, by inclined plane, you know what I'm talking about. It's like this. It's inclined at an angle like this. So this is an inclined plane. Okay, so the normal can be equal to mg cos theta. But I will show you later this one. So if force is supporting or in the same direction, the acceleration of that force will be positive. If a force is supporting the acceleration, okay, if the force is supporting the acceleration, that force will be positive. Now for the forces that will oppose or opposite direction, so the acceleration will be negative. Okay, now friction will always be the negative force, except for one question where it will be positive. I'll show you. Now let's have a simple question. Okay, let's have a simple question. Right, let's have a simple question. Okay, a 5 kg box is pushed by a 50 Newton force. Okay, so physics, like I said, is about drawing the free body diagrams. So the free body diagram actually to give you the roadmap of how you are going to solve that equation. Okay, yeah, like how Priscilla asked to say how can I be writing or drawing the free body diagrams. So let's have an example about this. So I have a 5 kg box which is pushed by a 50 Newton force. All right, so if the surface is flat, and the coefficient of kinetic friction is 0.2, draw a free body diagram and calculate the acceleration of the object, and calculate the acceleration of the object. Okay, so this box is being pushed by a 50 Newton, so that should be your picture in your mind. If the surface, now it's on the flat surface, and you have given the coefficient of kinetic friction to be 0.2. Okay, so now they want us to draw the free body diagram. So before we apply, let me draw solution. So I have this box on flat surface, right? This box is on flat surface, being pushed by a 50 Newton, like this. This is a 5 kg box, all right? So now there is a friction which is opposing this force which is applied here, all right? Okay. so don't mind the insects. Yeah, they have been attracted by the light. So okay, so here there is friction, which is kinetic friction. But actually here you can see that you are missing one force, which is perpendicular. So here there is, since it's a 5 kg, meaning there will be weight here down, which will be equal to mg. Okay, and at the top there's supposed to be a normal force. Now the 50 Newton and the friction should be drawn after they have had their effect. Right? The 50 Newton and the friction should be drawn after they had their effect. So the object is not sinking into the floor. The object is not sinking into the floor, meaning the floor is exerting a force on the 5 kg object. So this force is called the normal force. So the system at equilibrium is in the y-axis, right? So let's draw now the object with the forces after its effect, like what I've said. So you have an object which is on flat surface. So to have the normal force, to have now the 50 Newton will be going this side, the friction will be going this side, which is Fk, kinetic friction, and we have now the mg, which is the weight. Now since from here we're going to apply this Newton's second law of motion, now we will sum up the forces in the x and in the y. So we will sum the forces in the x and the forces in the y. Okay. The summation of forces in the x will be equal to the mass times acceleration, since it's the second law of motion. You know what the second law of motion states, and I introduced initially in the video the laws of motion. Okay. If I'm too fast, you can say, so that we move together. All right. Okay. So we continue. So the summation of forces in the x, it will be 50. Since I said on the friction, I said the friction force will always be negative, except for one question that I'll show you, or you actually read by yourself in the tutorial document. Like, I simplified everything there. So 50 newtons minus the friction. The friction is actually the Fk, should be equal to mass times the acceleration, since it's the second law of motion. So 50 minus the Fk can be replaced with what? The mu kn. The mu kn, which will be equal to mass times the acceleration. Okay. So 50 minus mu kn should be equal to the mass. We know the mass of the object. The mass is what? Is 5 kg. We don't know the acceleration actually. They want us to calculate the acceleration. We have drawn already the free body diagram they wanted us to draw. Now we are calculating the acceleration. Okay. The kinetic friction has already been given the question to say your kinetic friction is actually 0.2. Right? Okay, so from here. So this is our equation 1. This is the summation in the x. Now let's have the summation in the y. So summation of forces in the y. So that will be in the y. Okay. Summation of forces in the y. So in the y, this is the object. So this is the y-axis. If you do the axis, the y-axis is this one. So this one, in this alignment, we have the normal force and the weight. That's all. So we're going to say this normal force minus this. Since if you draw the axis, the weight is on the negative, right? So now we're going to say n minus mg should be equal to what? 0. It won't be equal to mass times acceleration. Okay, it will be equal to mass times acceleration, but the acceleration, because the object is at equilibrium, so that will give us what? 0, right? So meaning the normal force should be equal to mg actually. Okay. So now let's continue. So we have 50 minus mu kn, which will be equal to 5a, and actually in the y you have n, which is equal to mg. So the n, we're going to replace it with mg. The n, Since we know the normal should be equal to mg, so the n here on the equation 1, we're going to replace it with the mg. Alright? Okay, so 50 minus mu k mg should be equal to what? 5a. Okay, now we know that our mu k is 0.2. Our mu k is 0.2, and our acceleration due to gravity is 9.8. We know this by heart. By now, you know this by heart. Alright, so the mass you have, the mass is 5 kg. Now we can solve for acceleration from here. Okay, simple, right? Okay, easy stuff. Okay, so from here we can solve 50 minus 0.2 times 5 times 9.8, okay, should be equal to 5 times a. So if you multiply, so this will be 50 minus, if you multiply this all together, it's supposed to give you 9.8. This is 9.8. 9.8 should be equal to 5a, right? So 50 so 50 minus 9.8, that should give you 40.2. 40.2 supposed to give you, should be equal to 5a. Actually, here just a matter of, this is what I call the magic of number. So the acceleration will be equal to 40.2, you divide by 5, that should give you 8.04 meters per second squared. That's the units for acceleration. Don't forget to put the appropriate units at the end, because you can lose marks if you answer the question correctly but you put the wrong units. You reduce on your marks. Okay, so this is the final answer for acceleration. Now this video was actually the main focal point was showing how to draw the free body diagrams, because someone just requested to say, I don't know how to draw the free body diagram. So this should give you the head start. So you're on your own, on your free time, go through the tutorial document, understand how to draw the free body diagrams. So this has actually come to the end of the session. For those of you who have persevered to the end of the session, thank you very much for your attention, and have a blessed evening. Before we end the session, I just want to show you the question, actually the exam question, how you can go about it. Alright, let me show you. Okay, so this is the question now. This is the question. Okay, my camera can't seem to focus. Let me try to zoom a little bit. Okay, so here is the question. Here is the question. A block of mass m is placed on an incline that makes an angle theta with the horizontal. The block experiences kinetic friction as it slides downwards. Show that the coefficient of kinetic friction mu k is given by that. Mu k should be equal to tan theta minus acceleration over g cos theta. 7 marks. 7 free marks, you guys. These are free marks. Okay. Alright, thank you very much for your attention.